morning students, this is Junita Mukherjee from SS Public School once again, and in this particular chapter of class 9th physics we are in the chapter which is force and law of motion, and previously we have already been through the first and the second law of motion and about the inertia and mass, what is unbalanced and unbalanced force we have been through. So I told you we will continue with the mathematical formulation of the second law of motion, which is here written in this particular blackboard, which is called mathematical formulation of the second law of motion, and how it is being given, let us see. Now suppose an object of mass m is moving along a straight line with a initial velocity u. So the uniform acceleration to the velocity will be given by u, and v will be in time, and uniform acceleration will be given, or the last acceleration will be v from p2, okay, for the momentum of p2, and the initial and the final momentum will be p1 and p2, and the initial uniform accelerated motion from the final and the initial position and the final position will be v and u. V will be the final and u will be the initial position or the starting position, and then the force will be given by F and the time t will be given by t, and it is already given in your book. So initially the final and the initial momentum of the object will be given by P1 NU and P2 NV. Okay, so the change in momentum will be directly proportional to P2 minus P1. So P2 is the momentum of the final object and P1 is the momentum of the initial object. So initial object and final object, subtraction of these two. So MV is the initial, the final, and MP1 is the initial. So PU, MU. So if we take out M, so what will be left out? V minus U. So the rate of change of momentum will be directly proportional to M into V minus U upon T, and thus on the applied force F is directly proportional to M into V minus U by T, and thus F is equal to K into M into V minus U by T. So we will take this particular value, or you can take this particular motion into action. Suppose this particular value as if we know that this particular value is equal to A, as we have read in the previous chapter. So we have placed this, in place of this we have placed A. So this particular unit of force is the value given as K equal to 1 kg into 1 meter per second square. By taking the K constant into action, this is called the constant proportionality, or the proportionality constant we can say. Okay, and after this, this is what we have explained here, and this is what we call the proportionality constant or constant of proportionality, and the SI unit is given here for the force will be meter per second square and kg and meter per second square respectively, which is the mass, SI unit of mass. And if we are taking K equal to 1, then F will be equal to M into A in this particular equation. If we put this particular value, we will get F equal to M into A. Now, some more things are being given, that is unit of force is kg meter per second square or Newton, which has a symbol N, and the second law of motion gives us the method to measure the force acting on an object as a product of its mass and acceleration. The first law of motion can be mathematically stated as a mathematical expression for the second law of motion, that is F is equals to M into A, and F is equals to M into V minus U by T, that is we are taking the value of A into, substituting the value of A here, and if we cross multiply this value, that is F into T will be MV minus MU, that is F is equals to 0. If we are taking F equal to 0 and V equal to 0, V equal to U, then the particular thing, that is the observation or the velocity of the moving object will be there in the rest of obviously. So time taken T will be equal to obviously 0, because if we put this value equal to 0 and this particular value obviously will be equal to 0 again, so it will be in the rest position itself. Clear? Now we will move on to some of the questions related to this particular chapter. You go through this particular examples, and now the third third law of motion. I am going to explain. The third law of motion tells us that if there is a action and reaction in the from the first moving object to the second moving object, and equals force and action and reaction will be given by the second to the one itself. So that is, there is equal action to every reaction, or every action has an equal and opposite reaction. This is what we call the third law of motion. That is, for example, if we put a gun, okay, we are gun over this particular shoulder, and we are striking that particular gun into some particular object. When we throw this particular, when we press the material of the gun, and when we push the button, then what will happen to that? The arrow will hit that particular corner, and equal jerk will be obtaining in the shoulder itself. This is what we call the to every action there is equal and opposite reaction. For example, we can take an example of a sailor jump in a forward direction, the boat moves backward. This is a particular example. Now in conservation of momentum. So conservation of momentum will make you some points noted here. So I am taking you here in the conservation of momentum. So in the conservation of momentum, what happens? That is, there are two object balls A and B we have taken, and if we are taking this particular value as m A and with the velocity of UA, and MB with the velocity of UB. Okay, so it will collide, and what will happen? First will collide with the second, and A and B, and the force will be from A to B is AB, FAB, and from B to A will be FBA, and thus it will collide and meet to a certain position, and this will be the UAV velocity, and MB will have some velocity given by VB. Okay, so this is after collision, this is after collision, this is before collision, and during the collision it is moving on. So we can write that like this, that is MA is equals to BA minus UA by T, and we can write MB is equal to VB minus UB by T. Okay, like this we can write the two collisions. During the collisions, B is equals to FAB, and the change in the rate of change of momentum will be given by FAB, will be given by this thing, and FBA will be given by this thing. Now, what will happen to them? This will collide, and thus we will have the two frequencies given by FAB minus of FBA. These two will be equal to each other. Thus, it will be given like ABA minus UA by T will be equal to minus of MB, that is UB minus VB minus VB minus VB. This will be UB. Okay, and thus we will get the conclusion arrived at the solution, that is MAUA plus MBUB is equal to MAVA plus MBUV. This will be the value, and this is the total momentum of the two balls after the collision. This will happen, and from this equation we can derive many numerical problems as the solutions to which we are finding difficult in. So this is how, this is the initial state, this is the final state from FA to FB. Okay, and this will be the after collision state, and after collision the FAB will be like this, and FBA will be like this. Here it will be like this. MB. So this is the reason why the collision, after collision, it will have the total momentum of the two balls will be given by this ratio. We are just multiplying the value, and we are cancelling the value with T here. Okay, so this is how we are getting the solution. question answers of this particular chapter in the next video. I will tell you how to do the question answers of this particular chapter. I will tell you the answers related to this particular chapter in the next video. So before coming to the answers, if you have any queries related to this particular video or apart from it, you just comment in the comment section. So I will be eagerly waiting for your comments. Thank you, students.